Hi everyone, my name is Siamak and this is my geosynthetics podcast. So, welcome to this episode, guys. I have a special guest today and I have Ryan Hackney. Thank you, Ryan, for your
Yeah,
time
thank you for
speaking
having me.
with me and my audience today.
Yeah, thanks for having me.
No worries. So, Ryan, I want to start with the first question about your career. So, as far as I know, you come from the UK,
Yeah,
somehow new to Australia, but
fairly new, isn't it? 3 years now, so.
climatizing a bit.
Yeah,
So,
yeah.
but yeah, you have had lots of experience in the geosynthetics world. And yeah, if you can just tell us about your career as a brief to start with.
Yeah, okay. So my career, I'm one of those people whose whole career has been involved in geosynthetics. So it all started back in 2007. So I finished university in 2006, finished a bachelor's in geology, and then my aim was to then go on to a master's degree in engineering geology, but I either missed the deadline or the course was too full, so I had to wait a year before being able to sort of carry on with my academics. One of my friends was traveling to Spain at the time and he said, "Do you want to come along?" He was doing a little bit of renovation work there, so I spent about 6 months in Spain, and then we came back for Christmas, and I was then looking for jobs online and just seeing what was available just to tie me over for those 6 months until my course would start again that September. So yeah, I was Googling and I found a local job at a laboratory that wasn't too far from where I lived, and the description was a geosynthetics testing lab, so it involved sampling and testing geosynthetics. So I'd never heard of geosynthetics at the time, so went onto Google and had a quick look, and the first thing that came up was a Wikipedia article. So clicked on there and had a little bit of read about what a geomembrane was and a geotextile, geogrid, etc. And that gave me a little bit of background. Went to the interview and then luckily got the job. So thanks Wikipedia for that. And then so I started with the lab at that time in January 2007. And yeah, I remember my first day. I was punching out geomembrane seam tests, so the 25 mil thick tabs that you do the peel and shear assessments on, and it was all cutting those out manually with a manual guillotine, which was a bit of a nightmare, to be honest, but things progressed from there. And then that first week I remember conducting carbon black test in furnaces and operating universal test machines, and thought, this is pretty neat. I like this, and it's sort of, I enjoyed science at school and sort of being in the lab at school. So I that 6 months turned into 11 years. So there I spent 11 years at that specific laboratory, and sort of matured into a more senior role and managing the lab and looking after the quality systems. So ISO 17025 accreditations for laboratories and ISO 9001 accreditation. I managed all of those systems, and then had the opportunities to bring more testing in-house. So obviously looking into new equipment, and had the opportunity to develop new methodologies. So those 11 years quickly passed by, and I was fortunate enough to be able to do my master's course while still working as well. So I managed to do that on a part-time basis, and I managed to carry on working at the same time. So I sort of had the advantage of both worlds, I guess, being able to work and study at the same time. So I was very.
And the topic was around geosynthetics.
Yeah, well, it was engineering geology. So I sort of took a bit away from that, and I guess one of the main things at the time is that the lab I was working at, we didn't get into any shear testing at the time, and then from what I took from university and sort of looking at shear strength analysis, I was able to then bring that knowledge into the lab and purchase shearbox, and then start carrying out interface shear testing.
So the first 11 years was back in the UK?
Back in the UK, yeah, that's
and
right.
Since 2017,
2018. So I got to a period in my career and I thought, I'll have a look around and sort of what's the next step, what's the next challenge, what's the next natural progression. And I found this role that was still laboratory based, but it was more geared towards research and development. So it's exactly where I wanted to be, and sort of fortunate to come across that. And then flew over to Australia, had an interview, spent 2 days here, flew back to the UK. So I was a bit tired for that week, but a very worthwhile trip. And then we been in Australia now for the past 3 years, looking after the research and development laboratory. And
Perfect.
yeah, brought all my family here, and my wife always complained about the UK weather, so
she's happy
yeah,
here now.
she's happy here now. Yeah, can't complain.
That's good. That's good. No, perfect. And I think Gold Coast is one of the best places in Australia as well.
Yeah, it's not a bad place to be.
Exactly. So
and doing a job you love. So
oh yeah, absolutely. Yeah, that's perfect. So Ryan, you mentioned about your laboratory work and being always involved with testing different types of geosynthetics testing.
Yep.
So what sort of testing do you do on a daily basis, or now that you're more into research and development, what sort of testing you do?
Yeah, I mean, I guess it all started sort of when I was working back at the independent lab. You have exposure to the full array of geosynthetic materials, so all the existing ones we know of, and then new ones that are being developed in the background, and sort of being involved with international manufacturers and international projects. You get exposure to international specifications and international test standards as well. So
Sure.
I got good exposure to ASTMs and ISOs and DIN methods and Australian standards, and you get a good understanding for a tensile test is not just a tensile test, or a mass test is not just a mass test. There are some slight changes between how the different standards have been written, and so yeah, it's been a good background to sort of understand internationally how geosynthetics tested, and that not to always classify them as always technically equivalent. So that sort of covered sort of index-based tests in the past. So typical physical and mechanical and hydraulic type tests, where tests are ran to a specific set of conditions, and you're looking for a specific outcome to meet a specification. And then sort of as things progressed and you get involved with more site-specific testing, then you start to look at now more so is how geosynthetics interact with a specific environment. So more performance-based type testing that I get involved with now. So taking site-specific soils and site-specific pore waters and liquids and liquors and leachates and aggregates, and seeing how they interact with geosynthetics with site-specific conditions. It's really interesting to see how they're challenged and what the limitations are. And having that background in the full range of geosynthetic materials and tests, and because in the lab you're usually testing these materials to destruction. Most of the time you get to know what the limitations of materials are, and it helps you understand how to maybe better a product by understanding how they perform. So those site-specific tests, that's something I'm heavily involved with at the minute. So shear testing under specific loads with specific soils that are conditioned to a specific way, or protection efficiency testing of geomembranes, where we take specific aggregates and looking at how specific particle size distributions and angularities affect the strain on the geomembrane with certain types of geotextiles as well. Continuous filaments and staple fibers, they behave quite differently. So we get a really good understanding of how these different materials perform with specific types of rock, and building up that database is really handy and useful, and it's a good reference point. But yeah, I like the fact that every outcome's a little bit of an unknown, and the interpretation of that as well. So I guess you could say the same for chemical compatibility of GCLs, for example, as well. You're hydrating and permeating a bentonite with a site-specific leachate, so it's not like a standard index test where you might run a hydraulic conductivity test with deionized water. With a known source, you can pretty much predict how that's going to perform. But when you've got a specific liquor or a specific leachate with a slightly different chemistry, then it's really useful to be able to run these tests longer term as well. So in a sort of commercial lab, you're sort of limited to how long you can run tests for. It's all about sort of turning around tests and sort of putting numbers through. And for example, hydraulic conductivity testing, you could get a hydraulic value with deionized water within, say, 2 weeks. But what we're doing in sort of research is really push the boundaries and understand the long-term performance with specific leachates. So pass many pore volumes through and measure out chemical changes that occur over time. And we've got tests that have been running for 5, 6, 7 years now, and it really gives you that good understanding of long-term durability performance of specific raw materials.
So, that's perfect. So you sort of answered part of my next question actually about research and development. So basically from normal day-to-day testing of geosynthetic material in the R&D space, you basically want to push the boundaries.
That's right.
And you just mentioned about the passion you had when you were working in the lab in UK, and this role here in Australia is more developed around research. So why do you think research is important in geosynthetics generally, and then tell us about what you do in the research development area?
Okay, so obviously geosynthetics used in changing environments all the time. They're always being pushed to exceed what we expect of them. So being able to understand how you can maybe tweak a formulation or make some specific changes in a material to adapt it to a new application, I think that's really interesting and important. So good example, recent R&D I've been working on is exhumations. So obviously you can learn a lot from exhumations, and one specific example has been some geosynthetic sand containers that have been exposed in Queensland, and these specific containers were used as groins and seawalls, and they've been exposed for almost 20 years in situ. So getting that data and understanding how they're performing at that time is really valuable information. So in the lab you can obviously accelerate these tests to some degree. You can do accelerated UV aging, you can do immersion testing for hydrolysis or oxidation type testing, but really those tests, those durability type tests, are really still limited by a controlled method. They're running specific cycles for a specific time period at set temperatures, and it's still a controlled type test. So being able to take those exhumations and carry out tensile testing and look at things on a macro scale, and then look at things on a micro scale, so how individual fibers have changed over that time period. So we look at everything from how a single fiber is subject to abrasion down to the stabilization levels in them. We can learn a lot from that specific site, because again, with site-specific exhumations, the testing is unique to that specific location. So the temperatures fluctuate from large ranges as days and seasons change, and that you've got wind to take into account, and different types of moisture. You've got coastal conditions, inland dry conditions. So you can really learn a lot about how to maybe extrapolate some of those accelerated lab-based tests to a real-life scenario. I really enjoy being able to do those exhumations and gather that data and really see how material performs over an in-situ lifespan of 20 plus years.
Well, that's actually really interesting. Like you said, we do a lot of accelerated testing in the labs to sort of predict what's going to happen to this material. But you've had the chance to exhume material out of their real condition and then see how they perform. And it might be interesting also to go back and see what the designer's expectation was 20 years ago.
That's right.
And compare it with what's the current status of it.
I mean, these particular structures are sometimes designed as temporary structures, and then you come to 20 years down the line and you still find they've got 75+% retained of its original properties. It's really surprising how durable these materials can be. So we're learning a lot from that. And as I say, the big question at the minute, a structure or a application, it needs to have a service life of maybe 25 or 50 or 100 years. So you need a lot of data to be able to answer those questions. It's quite a difficult question to answer. So the more of these type of exhumations we do, a lot more that we can learn about long-term service durability, and especially in Australian conditions as well. It's quite an aggressive environment.
Exactly. Now, I think durability is a very hot topic, at least in our region, as you said, and it's very important that we do this research on the material, and we have this experience from 20-25 years ago that we can now refer to. So, Ryan, my next question is about your current task or assignment or engagement with ASICS, which is Australian chapter of International Geosynthetic Society. So you and I are now somehow colleagues, and we were in contact pretty regularly about different topics that we work together on the like different events or communications and topics that Australian chapter is involved with. So tell us about what your sort of previous knowledge of that was, and how do you see just the past couple of months of being involved with this society?
Yeah, so I've been quite fortunate to have exposures to the IGS from quite an early stage. So as I said, I sort of started getting involved with geosynthetics straight away from 2007, and had the chance and attended my first geosynthetic conference in 2008. So that was the EuroGeo4, so the European Conference on Geosynthetics. That was held in Edinburgh. I think it was September 2008, and yeah, that was my first sort of sight of the outside world of geosynthetics, not just what's happening in the lab. So it really opened my eyes as to so what else was going on internationally around the world. It was a really well organized event, and you sort of get good keynote speakers and the networking that takes place, and sort of the dinners that are taking place. I remember going to Stirling Castle and having a nice haggis meal. It really sort of sets you up for what's to come and things to look forward to. So that was my first sort of interaction with the IGS in Edinburgh, and then I was on holiday in Spain in 2012, and I was about 2 hours away from Valencia, so I took a day trip up to Valencia and met a few people there. So they're sort of again similar to EuroGeo4, and then again I had the opportunity in 2014 to attend the 10th International Conference on Geosynthetics in Berlin. So again, that was a huge, well-organized event, and international event this time. So there was everybody from around the world, Americas and Asias, and everybody to Australia and everything in between. So again, just gave me more passion to be involved with geosynthetics and see all the current work that's going on, because you get to see other people's research and things you're not always exposed to in the lab. So yeah, and then I never really had the opportunity to get involved with the IGS in the UK. So then when the opportunity arose here, obviously this is my time, and I'll apply, and then here we are. So yeah, the past 2 months have been great. I mean, as you know, we're a very active chapter, and we've got lots of things going on, and I'm quite excited for tasks and events that we've got planned for the future. So I'm really happy I can be involved with that.
Oh, absolutely. No, that's great to have you as part of the team, and we're all very passionate and excited about the future of the society here. So as my last question, Ryan, I just want to go back to your career again. So when you look back, I just did the math, so 11 years back in the UK, 3 years here, 14 years in the industry. What do you think was your maybe highlight of your career, something that you always remember, something that had a significant influence on you and your career?
I think most recently, having the opportunity to get involved in developing new products and taking that from an initial idea to then seeing that being fulfilled in a manufacturing facility. So I've had the opportunity to develop a new hybrid geosynthetic liner that's going to be used for containing emerging contaminants. So things such as PFAS that you see in the headline news and blockbuster films that are written about this. I'm really quite proud to have been involved in that and sort of test the initial concept and look at different materials that could be used, and then sort of come to an idea and then challenge that in the lab with different chemistries and liquors and see how that performs, and then to be able to then take that to an executive team and present our work, and then get the budget and the capital to then bring that to a manufacturing and bring that to the large scale. It's been really I've really enjoyed that process, and I hope we can certainly do more of that and look at new geosynthetics for the future and solving further problems as they arise.
Perfect. Yeah. Well, I think that's a great achievement. You come from that laboratory testing background and then focusing on research and development. So we always talk about research, and there's a lot of research happening in the geosynthetic world.
Yeah.
But that development part, which means the application part of the research, where you actually invent something new or improve something and come up with a new product. And you see that working is like, you know, watching, like the birth of a new product, and that's a massive achievement, and very interesting to be part of it.
Really proud to be part of that. So
perfect, very good. Thanks, Ryan. That's what we have time for today. So thank you to my audience and for watching this episode, and we catch you in the next episode. Thank you.
Bye.